Hi class, we meet again in the final part of ANOVA. Today, we'll discuss one-way ANOVA for unequal sample sizes together with the calculation of the confidence intervals. Before we start, I'd like to bring your attention to the question in ANOVA Part 2 video where we discuss this question about the one-way ANOVA test. Thank you to Aishwarya and Wong for discovering the mistake in the SSA calculation before this. So the totals was 60, 94, 102 and 127. Y dot dot was 383. The correct formula for SSA is 1 over n sum of squares of yi dot minus y dot dot square divided by capital N. So this would be 1 over 6 multiplied by 60 square plus 94 square plus 102 square plus 127 square minus y dot dot is 383 square divided by 24. And the answer is the same, which is 382.7917. Whether by design, accident or necessity, the number of subjects in each of the conditions in an experiment may not be equal. So when they are not equal, they are considered as missing values. And the ANOVA analysis could still be done. The only issue is that when the sample size are very unequal, it can actually affect the homogeneity of variance assumption that we have discussed in the part 1 video. But if the departure is smaller, then the ANOVA is actually insensitive from the assumption of the equality of variance. So let's analyze one-way ANOVA with unequal sample sizes. In this example, an electronics engineer is interested in the effect of tube conductivity on 5 different types of coating for cathode ray tubes in a telecommunications system display device. So the coating type would be the factor. There's only one factor. We'll be conducting the one-way ANOVA. There are 5 levels of treatment or 5 groups. In this case, K is equals to 5 and alpha is 0.05. Now, the number of observations or N is different for each coating type. So, for coating type 1, the number of observation is 4. And for the coating type 2, the number of observation is 3. We will deal with this later on. But first, the capital N or the total number of items are 18. How do you calculate that? You simply count the number of data that you have. So 1, 2, 3, 4 up to 18. Again, we need to find the yi dot, which is 580 in the first case. For the coating type 2, you simply add on 152 plus 149 plus 143 and you would get 444. Next, 526. 385, and 581. So y dot dot would be 2516. Meanwhile, y bar I dot would be 580 divided by the number of observations for coating type 1, which is 4. And you would get 145. Y bar 2, I think I'll simply jot down the formula here, would be y2 dot divided by the number of observations for coating type 2, which is 3. And you would get 148. And here, y bar 3 dot is 131.5. Next, 128.3333 and 145.25. Since y bar dot dot will never be asked, I am just leaving it empty for the time being. Okay class, what's the next step? Yes, to determine the null and alternative hypothesis. So the null hypothesis would be mu1 equals to mu2 up to mu5, and the alternative is also a constant. At least two of the means are different. Next is the calculation of the test statistics. But before we go into F star, we need to find the values of the SST, SSA, and SSE. And the formula is as given. So this would be the sum of squares of each of the data that we have. That would be 143 square plus 141 square up to 142 square. Minus y dot dot, we have it as 2516 square divided by the capital N was 18 just now, and this gives us 352,922 minus 2516 square over 18, which is 1241.1111. Next is the SSA. So you square the values of yi dot, which is as given here, 580 up to 581. 580. But class, look, this formula is a bit different than when the sample size are equal. Right? So the formula here is yi dot square divided by ni. So the value of n, or the number of observations, are different for each treatment, and we need to take into consideration this value. So I have here just now the value of y1 dot. Now I need to check for n1. So y1 dot is this, and n1 would be 4. y2 dot is 444, n2 would be 3. y3 dot is 526, and n3 would be 4. And n4 would be 3, and n5 would be 4. So we have here 580 divided by 4 plus, this is square, yeah? Because it's yi dot square. 444 square divided by the number of observations was 3, plus 526 square divided by 4, plus 385 square divided by 3, plus 581 square divided by 4 minus y dot dot square is 2516 square divided by 18. And this gives us 1098.6944. So SSE would be SST minus SSA and the value is 142.4167. So now we will transfer the SST, the SSA, and the SSE values into our ANOVA table. I'm rewriting the values here. So the degrees of freedom would be K minus 1, which is, K was 5, so 5 minus 1 will be 4. Degrees of freedom of error would be N minus K, where N is 18 minus 5 gives us 13. And degrees of freedom of total would be 13 plus 4, which is 17. Or capital N minus 1, which is 18 minus 1, 17. So MSA would be 1098.6944 divided by 4. And this is 274.6736. SSE 142.4167 divided by 13. This gives us 10.9551. And the test statistics would be MSA over MSE. So this is 25.0726, which is this value divided by this value. Plus, what's the next step? Perfect your rejection region. So, where's your rejection region for ANOVA? Yes, on your right hand side. And this is your rejection region of alpha 0.05. To find the critical value here, simply take f of 0.05 and the 2 degrees of freedom, which is 4, 13. Let's check the f table for f 0.05 for 13. 4. So 13 is between 12 and 14. You could take either one, and I'm choosing 14. So I have 4 and 14. Alpha is 0.05, which is the one here. So this would be our critical value, which is 3.11. This is 3.11. Let's compare our test statistics. It's definitely 25.07 falls in the rejection region. So class, what's the conclusion? F star falls in the rejection region. So we reject the null hypothesis. What do we conclude when we reject the null hypothesis? At least 2 of the means are different. But let's look at the example if there are any questions that needs to be answered. Here it goes. Were there any difference between the 5 quoting types at alpha 0.05? Since we rejected the null hypothesis, at least 2 of the means are different. So I would rewrite the conclusion as there is a difference between the 5 coating types. At alpha 0.05. Or choose only one, okay? You could write it as at least 2 of the means are not equal or are different. Or another way of writing it is, class, if you still remember, the coating type would affect the conductivity. Am I right? So the coating type affects the tube conductivity. You could write it as that. But this is closest to the question and I would choose this to answer. Let's look at the next question. Okay, you might also be asked to calculate the confidence interval of the treatment levels. And I would like to bring your attention here. This would be Ni depending on the observation of the treatment, and this would also be Ni. This is Ni. So the question says calculate a 95% confidence interval for the average for mu tube conductivity of coating type 2, so mu 2. So formula would be y bar 2 dot. So let's check what is y bar 2 dot. This value here 148. 148 plus minus t alpha over 2 would be 0.025 comma k multiplied by n minus 1 or ni minus 1. So our k is 5 multiplied by, so this is no more n but ni. Let me just write it out for you. Ni. What is n2? N2 would be 1, 2, 3, right? Okay, so it will be 3 minus 1 because it's n minus 1. Square root of MSE, I have here the value of MSE, which is 0.9551 divided by Ni, okay? So this will be 3, similar to the one here, right? Okay. So now our job is to find T 0.025. What is the degrees of freedom? 5 multiplied by 2, which is 10. So T 0.025, degrees of freedom, 10, gives us 2.228. We have here 148 plus minus 2.228 square root of MSE 0.9551 divided by Ni. And the answer is 143.7424, 152.2576. On to the next part. This is the final part actually. So previously we have learned this formula for the confidence interval of the difference in any two treatment means. Now this part changes, okay? This formula would be, instead of 2 MSE, it is MSE. Remember, we have different values of the number of observations. So we have Ni plus MSE So I for the first treatment mean and j for the next treatment mean and j square root. Okay, and again here MSE over Ni plus MSE over Nj. Okay, let's do the calculation. Construct a 95% confidence interval for the difference between mu4 minus mu3. So the 95% confidence interval for mu4 minus mu3 would be y bar 4 dot minus y bar 3 dot. So let's check what is y bar 4 dot and y bar 3 dot. The values are these. This is y bar 4 dot and this is y bar 3 dot. So we have 128.3333 minus 131.5 plus minus t alpha over 2 would be 0.025. How do we calculate the degrees of freedom, class? It's n minus k. So this 18 minus k is 5. That will be 13. And remember, it is square root MSE. And we have our MSE as 10.9551 over N4. So what is N4? N4 is 3 and N3 is 4. 3 plus MSE over N3 is 4. And let's check this value. T 0.02513 is this one here, 2.160. This gives us negative 8.6270, 2.2936. So 95% confidence interval for mu4 minus mu3 is as follows. Okay, class. So we are done with the ANOVA for unequal sample sizes. Thank you for your attention, and please don't forget your tutorial. Try it out, okay? And we'll discuss the questions soon. See you in the next video.